Cisco's hyperconvergence solution is called Cisco HyperFlex, and it's based on the Cisco servers, both rack mount servers as well as blade servers. So from the rack mount standpoint, it's the C220 and the C240 hardware, and the blade standpoint, we have the ability to use the B200 and M4 servers. So the platform consists of the hardware and the software. Now, what the software does is efficiently use and allocate space of the disk array or the disk itself inside the hardware, and make that disk subsystem available for the applications to consume. So this is the software that we acquired the IP. Now underneath it obviously is the servers themselves, and the way our servers are done is that we don't have to depend upon an all-flash disk for compression and dedupe. The way we have designed is that we have actually a hybrid environment. So there are spinning disks in our servers, and then there is also SSD for caching here. So what we are able to do is that we are able to use the functionality of a flash for caching, and we offload that cache onto spinning media at a later time when the HX data platform software finds it that it is time to offload it. So it will act and look like, from an IOPS standpoint, as a very fast, efficient storage, flash storage array to the system, with the ability for us to literally leverage the spinning media. So the intelligence, all of the intelligence resides here. And obviously, from the presentation standpoint, I mean, we want to make sure that this is accessible to the applications themselves. So here, let me draw the application tier. And the application tier, as you guys know, has typical reliance on a virtual infrastructure. Virtual infrastructure is nothing more than, for example, a VMware hypervisor. That's today. We have the ability to actually not only use the hypervisor, but also use Docker containers, and later down the road we will be able to completely eliminate the hypervisor and directly use the physical infrastructure as well. That's something that Cisco is working in the roadmap. Now what happens is that this HX data platform provides the connectivity and the management piece of the system subsystem to vCenter. Now vCenter is the management tool of choice for any VMware administrator. So VMware admins, day in and day out, they would log into this management tool called vCenter, and that's where they manage everything else. So one of the fundamental differences with our system is that we use no new tools to manage our system. Once the application is installed, once the cluster is up and running, a user can log into their vCenter environment, and for them it just looks like another data cluster that is part of vCenter. So no learning curve for that reason. Something else that we have done differently is that instead of embedding ourselves into the hypervisor, which would lock us in with one hypervisor, we have the ability to literally use a component, a very small piece that we call IO visor, which allows us to connect to the hypervisor of choice. So let's say this virtual infrastructure, I'm going to break it down to a handful of servers. So here's 3 servers, let's say, because I'm having 3 nodes. Each node will have its own hypervisor running on it. And what we have done is that we actually install another VM on each of the hypervisor. This is the management VM for HX. So HX software launches this, gets installed, and then on the hypervisor we embed a small software without getting into the kernel called IO visor. So there is the IO visor. All right, so that's the architecture. I know it says a lot of different things here, but the reason I'm drawing it out is to highlight a couple of things. The function of I/O visor is that the hypervisor does not have to have direct lines on the infrastructure, the physical infrastructure it's sitting on. We have the ability to load share amongst all the nodes on providing the actual data itself. So we have a shared pool where a VM could be split into multiple different destinations. And if a node fails, that VM really doesn't have to worry about what node it is on. It can spin up on the next node that is up and running, and we have the data itself is already available in multiple copies on the remainder of the nodes. All right, so what are some of the advantages now? Let me just highlight those things. One is that I can independently add disks to my nodes, which means I can buy a system with fewer disks, and when I need to increase my storage, I can add disks. I also have the ability to add nodes. So I can add a new node if I need more storage capacity as well as compute capacity. I can add another node with no disks, and I can increase the compute capacity. I can actually incorporate another blade infrastructure to it. So I can add a UCS B series to add more compute capacity into the cluster. Now, one of the fundamental differences that we have in terms of advantages is the fact that these nodes, obviously these compute nodes or these HX nodes, do have the requirement to communicate with each other because it's a clustered data. If you think about it, right? All the vendors have the same problem. That it's a clustered data. How do you make sure that they interact with each other? The data is moving across each other. The replication is happening. They have to rely upon a network, a robust network, right? And this network is usually a problem for every other vendor on getting this network up and running, making sure that the software understands how to program the network. And this is where the strength of UCS comes into play, because our solution comes with the network. It has the two fabric interconnects that UCS comprises of. So we will be typically what we do is that we ship I said typically, always we ship the system with a pair of UCS fabric interconnects, which is providing the network. So I'm going to draw all these lines. I know it's a lot of different lines, but what I'm able to do is the UCS fabric interconnects provide network connectivity. And by the way, the configuration of this, so that's a big question, right? How do you configure this? With UCS Director 6.0, which was released 2 days ago, we have a one-click install. So one click meaning once I got UCS Director up and running, and if the customer already has UCS Director, the workflow will install all the components, program all the ports, bring up the software, and then it can install the HyperFlex software on top of it. So pretty much a one-click install to get HX up and running in the new environment. So now what we are able to address is simplifying management and consumption of the storage subsystem, and simplifying the automation piece of the network itself. And then remember, because it's a UCS system, these infrastructure pieces or the physical servers are much more easier because the policy model that I talked about earlier. So I want to do a call to action and also give you some highlights of how do you tie the business problems to this solution, right? Business problem number one was agility and speed of application deployment. The fact that this is a system that totally obfuscates the storage element and brings it to vCenter, which is the management tool, a single tool to manage it. Now I can be able to deploy applications without having to worry about storage or network. Right? Those are the two components that typically are inhibitors on how quickly can I deploy an application. I also am able to provide the second bullet, which was the cost piece of it, right? The cloud-like agility and reduction of cost. The system brings the cost down for an enterprise customer because of the spinning media, and not having a need to purchase a very large enterprise class storage array. The third problem that I had described was the remote office, small office. This is perfect for a remote office. You can start with 3 nodes. That's ample horsepower, plenty of disk storage inside the system, and you don't have to worry about a data center. This could go into a small closet in a remote office or a branch office, and you have this system up and running, providing file, web, whatever applications that are required in the remote data center. This is the conclusion of part 1 of my video series. The second part, I will be discussing SDN and software-defined networking in data center, as well as security aspects inside the data center. Thank you.